friends, today we're talking about domain and range when we're talking about exponential functions. So grab your notebook, you're going to definitely want to take some notes and write this down. So let's start. First, for our notes, the big thing that you want to take away from today is that your domain is the same as your x, which is also the same as your input. For your range, you have y, which is the same as your output. Okay, and here are some other good notes. Your range, the way that we do this is we read from the bottom up. So we go from negative infinity on our y and we go up. For our domain, we start at negative infinity and go all the way over to the right, which is our positive. Okay, so the other thing we're going to talk about is set builder versus interval notation. These are two ways to write your domain. Some notes that you'll need for both set builder and interval. For set builder, you'll see something that looks like this: x and then a line and then another x. That is read as x such that x whatever is greater than 1, is equal to 5, things like that. Now, a lot of kids get messed up on less than and greater than. If you take a look here at this less than, you'll see it looks like a little L. So if you're looking at the symbol and it looks like an L, definitely a less than. Okay, interval notation. If you see brackets, these guys right here, in interval notation, that includes whatever we're doing there. So that's like if you had less than or equal to or greater than or equal to. That would be similar to what these are. These parentheses, those do not include. However, when we use infinity and negative infinity, they always get the parentheses. Another one, union and intersection, you'll need that both for set builder and interval notation. So here's an example. X is less than or equal to 7. So if I were to write this in set builder notation, I would say x such that x is less than or equal to 7. For interval notation, I sometimes find it helpful to write down to graph it out first and then write it down as my interval notation. Now you'll see that we start from negative infinity over here and we come in. It includes negative infinity, but again, negative infinity and positive infinity, they're not numbers. So even though it's included, we don't use the bracket, we use a parentheses always. So we've got negative infinity, and then we have something all the way up until we get to 7. Now 7 is included, so you'll see I'll have a bracket here. So that's the difference between those two. Okay, so let's talk about that when we have a graph. When we have a graph. So for our first one, here we go. We have a graph here, and here's the equation of that graph. So looking at this guy, you'll see that it's getting really close to this -3 here, but it's not crossing. That's going to be important. Let's start first with domain. So our domain here is going to be so it's our domain is x. So here's our domain. And here is our x. So we're going to go from negative infinity all the way to positive infinity. And I'm so sorry that that is focusing in and out. Hopefully that stops it. Okay, so for negative infinity, you'll see that this guy goes all the way until we get to negative infinity. So it's going to include negative infinity. Then we keep going, and this x, it goes all the way to positive infinity. So you'll see that it keeps going all the way, like I said, till positive infinity. So that means it includes from negative infinity to positive infinity. So for interval notation, what that looks like is we've got negative infinity, and remember we always use parentheses, to positive infinity. Okay, now for set builder notation, that is going to be x, whoops, I can never draw those. I'm doing this 20 years and I can never draw those little braces. X such that x equals all real numbers. And that R with the double line is an abbreviation for all real numbers. Okay, what about for range? So now we've got to talk about range. Range is our y. And as I mentioned, this guy right here is going to be pretty important. Let me draw that line a little thicker so you can see it. You'll see that the graph gets really close to -3, but it doesn't actually cross that. So what we do is we say, okay, it's everything. So we go from negative infinity in our y and we come up and it comes to this -3. And then we have something for everything on our y. And let me show you that with a pencil. We've got something for everything all the way up until positive infinity. So it's everything greater than -3. So for set builder notation, we would say our range is y such that y is greater than but not equal to 3. Can't be equal to 3 because this is an asymptote, so it's getting really close, but it's not going to cross it. Now, in terms of thinking about domain and range, let's do our interval notation. Let me write that down as our domain. And then for our range, we've got, so it's everything greater than -3. So we come from negative infinity, and the first time we encounter this is at -3, but it is not included. And then it goes all the way up to positive infinity. So now let's think about, when I said earlier, domain is your X, which is also your input, and your range is your Y, which is your output. That's the most important part of this video. You want to think about your input, restrictions on your input and your output. Restrictions on our input. We can put everything we want into, input is X, right? We're allowed to put decimals, fractions, negative numbers, things like that. However, when we put this in, let's ignore that -3 for a second. If we put in a negative number here, there's nothing that we can put in for X that will give us a negative number out. We're always going to have, the smallest number we can get is 0 by putting in a 1. If I put in -1, I would get +1/2. So the smallest number that I'm going to get is 0. 0 minus 3 gives me -3. This is why our range is -3. And we go into this a little more detail in another video, but I just wanted to explain that you've got to really think about what you're allowed to put in and what you're allowed to get out of your functions. All right, let's try another one. Okay, for this guy, we're going to do set builder, and we are going to do interval notation. Okay, so for the first one for domain, I'm going to give you a hint on this. For exponential functions, domain is, again, that's that restriction on input. We're allowed to put any number in for these X's right here and right here. There's no restriction on what we can and can't put in. So it's going to be all real numbers. So for exponential functions, your domain is always going to be all real numbers. So X such that X equals all real numbers. In interval notation, that would just look like this, -infinity to positive infinity. Okay, now let's talk about that range. Again, range is your Y, and it's coming from -infinity all the way up. You'll see the first time we encounter it is right here at 0. Kind of hard to draw a line on a black one there. And then it's everything greater than 0. So when it's greater than 0, we want our range Y such that Y is greater than but not equal to 0. For our interval notation, that looks like this. We come from -infinity and up, and then we get 0, but that's not included. And then we go to positive infinity. All right, one more so that you can see how this guy looks. So this one's a little different. You'll see that this one is opening downwards, down. So in this case, so again, we're going to do our set builder notation and then our interval notation. So for our domain, just like I said in the previous one, remember all real numbers for exponential functions. Not always, but it's not for every kind of function. It's just for these exponentials for right now. Domain is X such that X equals all real numbers. And as interval notation, that would be our -infinity to positive infinity. Now let's talk about range. You'll see that range, we come from -y all the way up, and you'll see that we've got, again, I should use a darker red there. You'll see that we have this asymptote, or this line that it's getting real close to, but it's not crossing. That is 1, 2, 3, 4, 5, -5. And we'll talk more about how to identify your asymptotes from your equations a little bit later. So, oh, sorry about that. I messed it up. So -5. Now you'll notice that everything is less than -5. So be careful about that. In this case, it's because it's a negative in the front here. So our range is going to be Y such that Y is less than, but not equal to. And remember, if it's less than, it looks like an L, -5. As interval notation, you would write that as -infinity, because remember, we start at -infinity down here and we come all the way up. It goes to -5, but it doesn't include it. So we stop it right there at -5. Hopefully this helped. We'll see you next time.